Okay, welcome back. Hope you enjoyed that exercise, setting up the federation, right? ADFS, and setting up the identity provider federation. Any case, now we move on to another new feature in vSphere 7, the vSphere Trust Authority. In this lesson, we're going to take a look at what is the vSphere Trust Authority, list the use cases of the vSphere Trust Authority, otherwise known as VTA, explain the general architecture of VTA, and configure VTA in a set of 3 different labs. So let's start off with a bit of history here with the more recent versions of vSphere. vSphere 6.5 and vSphere 6.7 were basically a turning point in making vSphere a far higher level of security or of a stronger security posture than previous versions in the past. And the VTA takes vSphere to the next level after that. So what do we have? In vSphere 6.5, there was an introduction of VM encryption. So what is this? This is the ability for ESX servers to encrypt your VM data as the VM is passing through the ESX server. We talked about the different storage policy components, right? One of the filters is encryption. And so we can encrypt the VM data as it's passing through the ESX server, and therefore now have the data encrypted in flight as it leaves the host, and it's going to encrypt the files on the resulting data store. Now, in order to do this, a key management server, a KMS server, is required to communicate through vCenter to hand off the keys to encrypt the VM information onto each of the different ESXi servers. As we see here, the VMDK files are encrypted, only accessible using a special key, right? You'll need to have a KMS registered with our vCenter server to perform this operation. vSphere access control restricts access to the digital key for decryption, right? In fact, in vCenter, there's a whole new model of principle of least privilege in that only authorized administrators can actually even perform the encryption tasks. In fact, that is the general vSphere admin, and then you go ahead and create other less security capable accounts in vCenter, making use of a new role that was added called the no cryptography admin. Right? We typically refer to this as the no crypto admin. This is some administrator who can do everything in vSphere except for encrypt VMs. So anyway, you can separate this out, right? In the security conscious sites, there's always going to be a separation of duties. You're only going to be able to perform the tasks that your job requires you to do, right? So in VM encryption, this is all handled through a method of transferring keys from a key management server to the vSphere servers. This is done through vCenter, right? In-flight data being encrypted. vSphere 7 added new features, such as being able to clone VMs that are encrypted, manage encrypted information in a content library, and even backup and restore. So also with HA, encryption mode is enabled on all hosts in the cluster for us. There's new APIs to improve management of VM encryption, and events and alarms exist now for monitoring the encryption in the environment. So this is a really powerful feature. It's handled through managing keys to encrypt the information by interacting through vCenter, as that is the only system that has a trusted connection to the KMS. The only limitation with that is that vCenter, because it's a major part of this handoff of the keys to the ESX servers, is that vCenter itself cannot be encrypted. It's too much in band there. So that's one thing that was added in 6.5. Another feature added in 6.5 was that the servers, the ESX servers themselves, support secure boot. You'll need UEFI firmware loaded up on those hosts, and those hosts are basically booting up into only in known good host configurations, right? An environment that lets the VM kernel load in a trusted platform of software. Now, in order for this to function, the firmware actually is signed with a digital certificate, which then validates the bootloader, which also has a digital signature. That one's actually provided by VMware. And then the server, if that bootloader passes the certificate verification test, will then start the boot process. Now, in vSphere, Secure Boot actually goes a couple steps further. Not only is the bootloader verified by the UEFI firmware, but that bootloader will validate what's called the Secure Boot VIB verifier. What's a VIB? That's a software package in vSphere, and every VIB, basically every software package in a host that's booted with Secure Boot, needs to have a digital signature. So basically, the bootloader is verified, every single software package is verified, so that no package, no software component has been manipulated before it's been booted, right? The hosts are going to be booting in a cryptographically clean method. If anything fails the verification test, the server fails boot, and it will actually result in a purple screen. So you'll find that your servers, if they're up and running, we know that they booted securely. If the servers are sitting at a purple screen, we know that they probably or maybe have failed secure boot. In fact, when the purple screen shows, it'll actually say that the secure boot failed, and it'll indicate which VIB failed the verification test. Now, the only thing here is that when you're looking at the vSphere client on a vSphere 6.5 system, you can only tell whether or not the server booted, and that's really about it. If a server fails its secure boot, it's sitting at a purple screen, the vSphere client will just show that the host is disconnected. That doesn't tell us a whole lot, right? We just know that the host did not boot, or it is not currently connected to vCenter. We don't know anything else. So that's really just telling us part of the story, right? So as you can see, there are really powerful features here, but there are some interesting pros and cons, right? I like the secure capabilities of VM encryption, but there's a major dependency of having everything through the key exchange happen to go through vCenter, which basically prevents us from being able to encrypt the vCenter system. With secure boot, this is great. The servers boot, proving they've booted cryptographically clean. However, if they fail boot, there's nothing that tells the vSphere client, nothing tells the admins through any kind of central monitoring system that's why the servers aren't connected to vCenter. They're just sitting there in a disconnected or an unconnected state. We need to actually go and dig a little bit further into the host to find out what's happening. So enter in vSphere 6.7. vSphere 6.7 added the support for TPM support, right? What's a trusted platform module, right? Or trusted platform chip. These are small little chips that plug into an ESX server's motherboard or any computer system's motherboard that do some important things. They generate cryptographic keys. They can actually store keys, and they can also perform what's called attestation. Essentially what these chips do is they interact with the stages of the boot process, the secure boot process, right? With these trusted platform module chips, they're effectively recording the stages of secure boot so that now it isn't just that the server has booted and we know it's booted, but we know actually each of the different stages in the secure boot process have all been recorded into this chip. And this chip has been also digitally signed, has cryptographic keys, can be configured to work to remotely attest or to have vCenter remotely attest this chip. What this allows for is vCenter can actually not just see that the host booted, but actually by securely communicating through a trusted connection between vCenter and the TPM chip on every single one of the hosts, you can actually log into the vSphere client and see under the security sections inside the vSphere client whether your servers have actually booted securely or not, whether or not their TPM chips have been actually implemented or not. So TPM chips only are relevant if you're booting your server with secure boot, and will also be able to report to vCenter about the status of their secure boot. So if anything fails secure boot, you'll see it in the vSphere client with an alert. So it's primarily about recording the stages in the registers in the chips and being able to establish a trusted connection with vCenter so that vCenter can remotely attest the identity of the host, but also the status of their boot process. So remote attestation authenticates and attests to the state of the host software at any given point in time. And then the hardware is then used. It's just a little chip that gets plugged into your motherboard, which are then going to store all the stages of the boot process. These recorded states are called a quote, and the quote is then something that can be sent to vCenter, to vCenter's knowledge. So vCenter can report this knowledge on the status of that host's boot process. So the remote attestation process, with having ESX servers with secure boot enabled and their TPM chips on board, the vCenter server can establish the trustworthiness of the remote TPM on the host by will create what's called an attestation key, and then vCenter will then retrieve the attestation report from the host. The report contains that quote that was contained on the registers, signed by the attestation key, and vCenter will verify the authenticity of that signed quote from the host. And if the signed quote is invalid, remote attestation fails and the host is actually not trusted. But there's really no adverse effect of this, right? You just can see in the vSphere client through an alert that a host has either not done its secure boot or that its remote attestation happens to have failed. But if the server actually has booted, it will still be able to function and run workloads. Is that a trusted platform to run your workload? That's where customers have to decide. So one thing about TPM 2.0, it does require vSphere 6.7. It is both on vCenter, ESX servers. The ESX servers need to have one of these TPM chips on board, which a lot of times they come on the servers as they're purchased. You can check that in the order for your hardware. It's usually a $20 option. It's a small little chip, and usually they can be retrofitted on pretty much servers built within the past 10 years. So you just make sure you get a brand new TPM chip from the vendor that you purchased the hardware from. Don't go out and buy a TPM chip on eBay or anything like that, because the TPM chip is actually bound to the server that it was first implemented on. So once you take that chip out of that server, it is no longer useful. So never buy a used TPM chip. It won't function. But get the new chips from the manufacturers. They are actually signed by the manufacturer so that they are designed to work on the hardware that you're plugging them into. So just some little bit of history here, right? In 6.5 and 6.7, we found VM encryption, which is a great way to encrypt your VM data in flight and also storing all the data on storage already encrypted, all handled through the ESX server. The elegance of VM encryption is that no extra agents are needed in your VM or on storage. It's all handled through the VM kernel, but the key exchange is through vCenter. The limitation there is then the vCenter server cannot be encrypted. With the secure boot, another great way to prove that a server has booted cleanly and cryptographically clean. However, with secure boot, without a TPM chip, all we can tell is whether or not the server booted, or maybe we don't know what happened to that server, right? If the server is at a purple screen because it failed to secure boot, that's not going to give you any error messages other than the host is disconnected from the vCenter system. The TPM chip adds that extra step where we can then have remote attestation provided through vCenter's association with these TPM chips, and vCenter can report the status of the secure boot and the attestation of the server's authenticity. That can all be reported in the vSphere client. However, the issue with this is that's all it does. It reports that the host has either booted securely or that it has passed or failed its attestation process. If the server actually has booted, well, we haven't really got a full level of trust just yet. We just know that the server has booted without really knowing whether or not we have trusted the TPM chip. So if that trust hasn't been established yet, then it's always a possibility that that may not be a trusted host. If it's part of a DRS cluster, DRS doesn't care. It's going to vMotion a VM anywhere. So you can imagine a VM that's on trusted systems might be able to be migrated to untrusted systems. The reporting mechanism with 6.7's TPM 2.0 remote attestation is pretty much a reporting read-only function, right? There's no real adverse effects if anything fails attestation. So the solution is what's coming up next, the vSphere Trusted Authority. So stay tuned. We'll take a quick break and we'll start diving in the overview of the vSphere Trusted Authority. So we'll see you in a few minutes.